This is what about the Newton's first law. So entire Newton's first law, that is why we can say Newton's first law has been taken from Mr. Galileo experiment. That is why Newton's first law also we can call it as law of inertia, or we can say Galileo law of inertia. What is to call? Galileo law of inertia. Okay. So this is first law. Now let us move to the Newton's second law of motion. So if you want to understand the Newton's second law of motion, so you all need to remember that the one which we already studied, the concept called as momentum. How many of you remember the momentum concept? Everybody? Newton's second law of motion. So let us recall the momentum. What is momentum formula? P is equals to fastly. I have taught you or not? Momentum P is equals to the symbol of
Mass
momentum.
into velocity.
You all remember or not? Momentum P is equals to mass into velocity. So momentum is a vector quantity or scalar quantity? Fastly. Momentum is a
Vector
vector quantity. So what is the units of momentum, everybody? Mass is kilogram, velocity is meter per second. These are the SI unit of momentum. Am I right or wrong, everybody? Yes? All of you? Yeah.
Yes,
So
sir.
what is Newton's second law of motion? All of you observe very carefully. It's very simple. So Newton's second law of motion, you can see when a force acting on a body, the momentum of the body changes. Will you all agree with me, everybody? For example, your car, you are sitting in your car. Now you will start your car. Your car is traveling with a 10 meter per second. After some time, by pressing the accelerator, your car speed become 20 meter per second, velocity 30 meter per second, 40 meter per second. Now you tell me, is your car is possessing the same momentum or momentum is changing when the speed changes? Everybody. Momentum is changing when the speed is changes. That is what is my question to you all guys. Yes, please.
So momentum will
Remains constant or changes when the speed of the body is increasing? Of course, you tell me.
changes.
Momentum concept will apply only for the objects which are in motion or which are in state of rest. That is what my first question. Everybody. Momentum is applicable to only the objects are in motion or objects are in state of rest.
Motion.
Objects
All
are
the
in
bodies, sir.
motion. Because we all knows that if the object is in rest, velocity becomes zero. If velocity is zero means what is the momentum possessed by the body? Everybody. Momentum possessed by the body is what? Everyone?
Zero.
Zero.
Momentum is only shown by the objects who is in what? Everyone. Momentum is only shown by the objects who is in
Motion.
motion. That is the first thing. Now, we already calculated. For example, let me take now your car mass is, all of you observe very carefully. Your car mass is some, let me take 100 kg. What is your car mass now? 100 kg. So you are traveling with a velocity V1 with a 10 meter per second. So can you tell me what is the momentum? Momentum is equals to 100 into 10, which is equals to how much, guys? 1000 kilogram meter per second. That is what the momentum. Am I right or wrong? Yes. Now, your same car, what is the mass, guys? Mass is equals to 100 kg. Now, velocity become, let me take 50 meter per second. Now, can you tell me what is the momentum? 100 into 50, which is equals to how much, Ra? 5000 kilogram meter per second. You understanding? So, if the amount of force is increasing, how this velocity increases? By applying the force or by not applying the force? Everybody. Is the velocity will increases automatically without applying the force? That is what my first question. Yes or no? Yes, everybody. Velocity of the car is changing. Is it possible to change without applying the force? That is what my first question to you. Do you understand what I am asking?
No, sir.
No.
No, sir.
So now, if I apply more force, my car velocity becomes 200 meter per second. If I apply less force, my car velocity become maybe 30 meter per second. Now, definitely there is a change in the speed. So if the velocity of the body changes, then the momentum will change or not will change. Everybody. Momentum will change or not? Fastly, everyone. Try to think.
Yes, sir.
Momentum will change. So when a force acting on the body, the momentum of the body 100% will changes. So larger the force, greater will be the change in momentum. So that is what Newton's second law of motion will says, that when a body is experiencing the large amount of force, the momentum also will changes in a greater amount. If the force applied on a body is less, then the change in momentum is also extremely low. So that is what
Suppose it is saying that the velocity, if it is high, means like that.
momentum is high. Momentum is high. But when the velocity is high,
velocity is low
if
means
you apply the more mass,
momentum.
more force, am I right or wrong? If
Yes,
you
sir.
want to increase the velocity, you need to apply the greater force or lesser force?
It,
Greater force. Yes or no?
it denotes the velocity, sir.
Yes?
Force denotes the velocity, sir.
Yes, force is only will changes the velocity. Am I right or wrong?
Yes, sir.
That is what. Okay. So all of you write it. When a force acts on a body, 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 the momentum of the body changes or not changes? The momentum of the body changes. Larger the force, greater will be the change in momentum. Is it okay, guys? Everybody? Yes, please. All of you? Then write the definition of Newton's second law. Definition. Very, very important. Then only I will teach you the derivation. You all should learn the definition. Then only we'll learn the derivation. Definition, right? The rate of change of momentum of a body. The rate of, wherever you will get a rate, by this time you should say, with respect to what? Mr. Lingesh, acceleration also remember. Rate of change of velocity. Same way here. Newton's second law says that the rate of change of what? Everybody. Rate of change of what, Ra? Rate
Velocity.
of change of momentum.
Momentum.
Yeah, rate of change of momentum of a body is directly proportional to somebody. Can you tell me whom that?
Rate of change of
Force,
velocity.
Mari, proportional to force. Am I right or wrong?
Yes, sir. Due to force and velocities.
Yes. Net force acting on it. Net force acting on it and takes place in the direction of the net force. This is very, very important. Direction of net force. Okay. So momentum changes in the same direction of net force. That is what you have to remember. So this is only I can write the meaning of it. The force is directly proportional to change in momentum. So change means I told you already. Delta. Change in velocity. Do you remember acceleration means what is the formula we have written? You all should speak. Final velocity minus initial velocity divided by time. So change in velocity we have written as a delta V divided by change in time means delta T. Do you all remember or not, everyone? I want to know.
Yes, sir.
Yes?
Yes, sir.
Yes, that is what. So the same here. Force is directly proportional to change in momentum divided by time taken to change that momentum. So that is only called as Newton's second law. Very, very important. 11th class also you will get it the same thing. Newton's second law means the net external force is equals to dP by dt or delta P by delta T. That is what you should remember. Okay. Mr. Sanjay, Mr. Darshan, Gokul Ras, this is what about it. Okay. Now, let us make the derivation of Newton's second law. So, it is a very popular law. So, we all people knows. So, derivation of F equals to ma. This is only called as, what is that called as? A well-known equation of Newton's second law. Okay. So force
Sir,
is,
A is acceleration, sir.
yeah, force is equals to mass into acceleration. Force exerted on a body is equals to mass of the body into acceleration of the body. But
Sir, I'm unable to understand that F is proportional to change of momentum by change of
here,
time.
the rate of change of momentum means what? Change in momentum by change in time. Am I right or wrong? Is directly proportional. Directly proportional means this is the symbol to the net force acting on it. That is what the force. That's all. So F, the net force acting on the body is directly proportional to change in momentum divided by change in time period. That's all.
Yes, sir.
Okay, that is. Now listen. This is the equation, actually the standard equation of Newton's second law. But this equation is not always true in many cases. 11th class you will study. So that is why the most standard equation for which is always remains true for a Newton's second law, that is what? F is equals to dp by dt. This is the most standard equation for Newton's second law. But class 9th students knows this. But this is the more standard form and which is always remains true. F net is equals to dp by dt. So that is what you should remember. Okay. So let us derive this formula and we will make it. So let me consider there is a body or a car. Let me take a car whose mass is m. What is the mass, everybody? Whose mass is
M.
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 And whose initial velocity is u. Okay. And having a initial momentum is p1. What is the initial momentum, everybody?
P1.
Initial momentum is p1. Now, some force is applied on the object. Some force is applied on the object so that its velocity become v. Okay. And mass is remains constant so that the momentum become p2. Is it okay, everybody? Momentum become what? Momentum become what? P2.
P2.
Okay. So of course, F force is acting on it. F force is acting on it during a time interval of delta t. What is the time interval, everybody? During a time interval of delta t. Clear? Respond, Ra. All of you? Yes.
Yes,
That is what. Now,
Yes, sir.
change in time. Change in time delta t in momentum. What is the change in momentum in a delta time period, everybody? Change in momentum means what? Final momentum minus
Initial.
final momentum minus initial momentum. Like change in velocity, acceleration. We all knows that. What is the change in velocity, acceleration formula? Change in velocity means what we have done? Final velocity minus, everybody, initial velocity.
Initial
Same thing here. Okay. So change in momentum in a time period delta t, which is equals to p2 by p2 minus p1. Okay. Now, rate of change of momentum. Whenever you will get a rate of change of momentum with respect to what? Rate of change of momentum. Rate of change of momentum means with respect to a time period. So P2 minus P1 divided by delta T. So this is what is actually Newton's second law. Now let me take the P1. So what is the P1 for momentum formula? Everybody verify it here. What is the momentum formula? P1 is equals to mass into initial velocity. So here P2 is equals to what? Mass into fastly. Mass into final velocity.
Final velocity.
Yes or no? That's all. So you can write it. So we all knows that P1 is equals to mass into initial velocity and P2 is equals to mass into final velocity. So substitute in the formula. So rate of change of momentum is equals to rate of change of momentum is equals to P2 minus P1. So what is the P2 value? M into V minus P1 value m into u divided by change in time delta t. So in this m is common. So m I will take it outside. Now observe very carefully. What is remaining? Final velocity minus initial velocity divided by delta t. So we all knows that this is change in velocity. Mass is remains constant. So rate of change of momentum only we used to called as second law. Okay. So F is equals to m into what is the change velocity law? Final velocity minus initial velocity by delta t, which is equals to something. Can you tell me? We all knows that. What is that?
Acceleration.
Acceleration. So
Acceleration.
acceleration is equals to change in velocity by change in time period. That's all. So this I can write as
So one doubt, sir.
yes.
So rate of change of momentum means force acted on it.
Yes. Rate of change of momentum only force, which is
Yes,
equals
sir.
to force, correct, Mari? Beginning we have done or not? Rate of change of
Yes, sir.
momentum is directly proportional to force. Clear?
Yes, sir.
That is. So F is equals to, what is that happening? M into dV by dt. So dV by dt is equals to what, guys? We all knows that. dV by dt is equals to what? All of you.
Acceleration.
Acceleration. Understanding? So that's all you have to remember it. And here, even we can directly, you can mention it here in the side and you can write it. F is equals to m into dv by dt. So F is equals to m into dv by dt. It equals to acceleration. That's all. So this is only the Newton's second law. So Newton's second law will says what? Newton's second law of motion. It will establishes that unbalanced external force is required to accelerate the body. So it is a vector quantity or scalar quantity. This force is a vector quantity or scalar quantity. It has a direction. So it has a, it is what?
Quantity.
It is the
Vector quantity.
vector quantity. That is what you should remember it. So this is what about Newton's second law derivation. Ellame puriyuma Newton's second law. Agalya, understand? Shivani, Alfin,
Yes, sir.
that is. So Newton's
Sir,
second law
but the
derivation.
standard formula is
Yes.
change rate of change
Change
of
in momentum divided by
momentum
change
by
in time
change in
period.
time.
Okay. This is actually popular formula, but this formula is not always true. 11th class you will get the situations in which situation it is not true. But this is the formula which is always remains true. Clear?
Yes,
Every situation. That is what. Clear? Understood, Amma? Everyone? All of you?
yes, sir.
Yes, sir.
Yes. Now, let us write the dimensions. And tomorrow we'll study the units. Let us write the dimensions. Can you tell me dimensional formula? Dimensional formula of force. I want to know. Please mute yourself, somebody. Dimensional formula of force. Let me see who will say first. So we all knows that. Tomorrow I will teach you the units. Now let me write the formula alone. Mass into acceleration. Dimensional formula of mass. Mass means what? We have to write in the form of m, l, t. So mass means m. Am I right or wrong, everybody?
Yes, sir.
Yes, m power 1 into. So or else you write the units first. Finish it. Mass means kilogram. Acceleration means what? Fastly. Meter per
Meter per second.
square.
Meter per second square.
Kilogram means mass. Meter means length. M power 1, L power 1 divided by S means time. T power 2. So what is the dimensions? Fastly. M power 1, L power 1, T power,
T power minus 2.
T power minus 2. Very good.
Yes.
Clear? Kishore, A power illara, L power. L power. Ellame purima. Understand or not?
Yes,
So
sir.
what is the dimensional formula of force, everybody? M power 1, L power 1, T power minus 2. If you write the units, you all people can understand. Is it okay, va? Everyone?
Yes.
Yes.
Yes, sir.
Yeah, momentum, what is the formula? Momentum, mass into, that is what? Kilogram meter per second alone. So what will happen? M power 1, L power 1, T power minus, T power minus 1. Understand, Mr. Gokul? But here second square. So that is why it is T power minus 2. Okay, va? Yes?
Yes, sir.
Yeah.
Yes, sir.
So this is what about it. Then tomorrow we'll study the relation, that units of force and as well as relation between the different units of forces. And then tomorrow there is a concept called as impulse. So impulse is the most important one. in the entire class 11, that is what impulsive force and as well as impulse, and what is the dimensional formula of impulse. These are all the things we'll discuss in our tomorrow's class, and we'll solve the examples. Tomorrow definitely I'll take the class and I'll teach you till mass and weight. Then once it is over, then from the Newton's third law of motion, we'll study after the PT one. So that from Monday, we'll go with the revision of first chapter and we'll continue. Okay, guys. So this is what about the today's class. I hope you all learned everything today. Anybody having any doubt, you can ask me. So otherwise, you can leave from the meeting. Thank you, everybody.